Thank you all for coming. Thank you, Eileen, for the very gracious, generous introduction. I'm going to talk about, I'm going to do a kind of political history here of how did we get to where we are. I chose to do it in, the theme is in purple, because it's not going to be a partisan talk. And except for one thing, I am an unabashed advocate for stem cells. And so I judge politicians and ballot propositions and all these kinds of things on one basis, and that is it good for promoting stem cell research? Because I passionately believe this is where medicine needs to go and can go. Now, if I can figure out how this arrangement works. All right. A tiny bit of reiteration of science, and then I'm going to delve into what's very current that we're all talking about, which is politics and politicians and votes. When somebody says to you, will stem cells cure this or treat that, or can we use stem cells? Your first answer should be, what kind of stem cell? Because stem cells are not all created equal. They're very different. The controversy arose in 1998 when it was shown to us that you could make human embryonic stem cells. Now, I'm going to show you how that's done and why it became controversial. So here's a source from human 4-day embryos that are obtained from in vitro fertilization clinics. These are generally discarded materials. A second source was an attempt to create those in a laboratory. We don't do this here. That's why I put it in light. In fact, there's only a handful of labs around the world that do it. But it uses a technology that is identical to that, or nearly identical to that was used to clone animals. So you remember Dolly the sheep? That's that technology where you transfer nucleus of an adult cell into an egg cell that has had the nucleus removed. It is politically potent issue. It's a scientifically sidetracked, minor, doesn't affect much of anything going on issue, in my view. Largely because it was replaced by this technology. In 2006, Shinya Yamanaka in Japan published on how you could take an adult cell and reprogram it genetically and make it think and act as if it's an embryo or an embryonic cell. So you can take an adult cell and reprogram them so that they function like these first cells. And if you can do that, you don't need all this apparatus of transferring nuclei and so on. There are fetal cells. And if you want controversies from cloning and embryos, you get it also, and perhaps even more so, with fetal cells. We'll talk a bit about why fetal cells and what the politics of that is. And finally, there's adult cells. We've been using stem cells clinically since the 1970s for the treatment of blood diseases, for leukemias and things like that. And those are an adult stem cell that can make blood. They don't make other tissues. You get them from bone marrow, or you can get them from umbilical cord, but they repopulate only the blood system. And so these different cells have different properties and different issues. The embryo cells and the iPS cells can grow very extensively. They can make any cell type, or almost any cell type. Whereas the adult cells can only make a very limited tissue-specific kind of cell. So the ones that grow indefinitely pose different questions about how you're going to produce them and market them than the ones that have a very limited growth, where you have to keep going back to other sources to get new ones. They raise different ethical and policy issues. So it's very important to know what kind of stem cells we're arguing about. Or as in this cartoon points out, what the issues tend to be are not scientific, but religion and politics. Now, I'm not going to talk about religion very much, because I don't know theology very well, but I do know a bit about politics. I was actually living in Washington when working on this organization, FASEP, when a lot of this controversy emerged. So I have the kind of scientist's eye view of what was going on at the time. A lot of the controversy ranges around this process, where in vitro fertilization clinic would take an egg and sperm in a test tube, actually a petri dish or flask, and in 4 or 5 days outside the body, create this structure called a blastocyst. It's about 100 cells, 120, 150 cells. It has 2 cell types, one that makes the placenta and one that makes everything else. If you take these inner cells, you can grow them outside the body, which is what we call a stem cell line, and you can make any cell type you want out of it. Of course, once you've done that, this structure is destroyed and unable to go on to what would have been its total potential, which is a baby. Just to give you a feel for this blastocyst, there it is, giving you a size comparison, lodged, of course, in the eye of a needle. Just to give you a little feel, this was done by somebody who wanted to have a picture in the National Geographic, and succeeded. If you took a dime, you could line up on the groove of a dime about 10 to 15 blastocysts. So they're a very tiny structure with only 2 cell types. They don't have any sensory organs. They have no nerves, no way to sense the environment, feel pain or any such thing. They have no limbs. They've just got potential. They came on the scene in 1998. They were described. So let's take a look at the political environment in that period, where we tried to figure out a policy for them. Bill Clinton was president. The next year, there was a trial for impeachment. The year after the stem cells is unrelated, I believe. But there was a Republican control of the House of Representatives and the Senate, although in 2001 it was an evenly divided Senate when one senator switched sides. And then in 2001, George W. Bush became president and gave a major speech on stem cells in August of 2001. We're going to talk a little bit about that. Of course, the next month we were attacked. Other issues came up, such as wars in Afghanistan and Iraq, financial crisis, recession, and although stem cells were not the presidential campaign issue that people thought they might be, they remain on the political scene as an important issue, despite the fact that there were all these other momentous events happening. And part of the reason was that people lobbied hard. And there were passionate groups lobbying on both sides. There was a anti-stem cell group with views primarily based on their religious principles, largely anti-abortion activists, although that's not a one-to-one relationship. I'll talk a little bit more about that later. And they argued, well, we really don't need these things. Adult stem cells are just as good. An argument that nobody really bought because we hadn't tested them, so we didn't know how good they were going to be. Or that they would lead to terrible things like cloned people or embryo farms. On the other side were patients, largely. Number one were patient advocates. The first group that was on the scene was the Juvenile Diabetes Research Foundation, There was then a group called Cures Now, which is kind of the ancestor of a group that Mitra works with, of activists who sought to use stem cells for disease treatment. There were a bunch of science organizations, including the one I was working with. 40 Nobel laureates signed up and said we ought to be using this. And some public figures such as Nancy Reagan, Christopher Reeve, Michael J. Fox. And the end result was something we called the Bush Compromise. This was 2001, and President Bush issued a government policy, a presidential policy, that federal funding, which is the only thing he could directly control, would be available only for those cell lines that were in existence at that moment, which was said to be about 66, but actually turned out to be about 20 or 21. The others were not usable. And there would be no funding for nuclear transfer research. So it wasn't a complete ban on stem cell research. It wasn't a statement that we could have to cease all this now. But it was nothing new. And we have to make do with this handful, this 24 cell lines, and no more. Now, it turned out that some of them were quite useful. And many of them were useful for determining a kind of proof of principle. But it was an enormous limitation to the field, so much so that it was not well greeted. This is a cartoon from that period of a putative congressional hearing saying, but other than that, how are Bush's stem cell guidelines affecting your ability to conduct research? To the scientist who's all tied up and unable to comment. In fact, it was not a popular policy. And this is a poll from the period. This is 2004, in which the polling question was, should we reverse this limitation of no new cell lines for stem cell research? And 74% of the respondents said, yes, we ought to reverse this. And while it was clearly influenced by political inclinations, even self-identified conservatives, a majority, a substantial majority, said we ought to reverse this. This isn't working. We're limiting ourselves for no purpose. This then came to legislation. And I think this is a crucial point in the history of this field. In 2005 and again 2007, a bipartisan proposal in the House of Representatives by Republican Mike Castle of Delaware and Democrat Diane DeGette of Colorado said, let's just simply get rid of that limit. We don't need that limit of August 20, 2001. Let's make some new ones and get on with this field. It passed in the House, even though, and this was a Republican-controlled House, and it passed in the Senate with a remarkable vote in which 4 senators who went on to become nominees of their party for president all voted for it. Kerry, Obama, Clinton among Democrats, McCain. And I think most notable was that 19 Republican senators voted for this legislation. It was vetoed. It did not get the votes to override the veto in the House of Representatives, so it never went back to the Senate. In 2 tries, it was passed again in 2007 with the same result. There was also some Senate legislation proposed on a so-called research cloning bill, with the most amazing coalition of senators you're ever likely to see on one bill, with Orrin Hatch, Arlen Specter, and Strom Thurmond as Republicans, and Tom Harkin, Ted Kennedy, and Dianne Feinstein as Democrats. Constructed a very interesting bill to support stem cell research in a variety of ways, and it never got out of committee. In my view, this was the moment when bipartisanship was lost. it's, I think, a tragic moment in the history of stem cell policy in this country because we weren't able to capture the bipartisan feelings that we could have a pro-stem cell policy. The one thing we did have, we've had since 1995, is a piece of legislation called the Dickey-Wicker Amendment. Dickey-Wicker just affects the NIH budget. It was a one-time piece of legislation in 1995, but it's been renewed annually every year since to the annual appropriations. And it says you cannot use federal dollars to create an embryo or to kill an embryo for research. And so in the stem cell field, if you were deriving stem cells from these in vitro fertilization products, you had to use other money to make the original derivation of the cell line. And then you could use federal dollars to study it. There was lawsuits about that and trying to say, no, that's it should ban it entirely, this amendment. The courts threw that out and that litigation was dismissed. So from the political standpoint, we've got a problem here. We had close to a bipartisan consensus, and then the key supporters began to disappear, particularly among the Republicans. Senator Thurmond died. Senator Gordon Smith from Oregon, who was the most eloquent proponent of a position on a kind of religious basis, that you could be strongly anti-abortion and still pro-stem cell. And he was defeated in 2008. Senator Specter was defeated in 2010. He'd already switched to Democrats. He got defeated there. Senator Hatch kind of withdrew from the field, but he's still been in office and will be until January. Representative Castle, who was important, was defeated for a Senate nomination in 2010. You may remember this one. His opponent was the woman who kept having to deny that she was a witch. Representative Duke Cunningham from San Diego area was a passionate supporter of stem cell research until he went to prison.
Who's the witch? That's the problem then.
Pardon me?
Who's the witch?
Oh, what was her name? She was the candidate, the Republican candidate in Delaware. She was defeated by Senator Coons. But she got the Republican nomination instead of Mike Castle. There have been a number of governors, Republican governors, who've supported this in various states. They've all either been, most of them have retired. Governor Ehrlich in Maryland was defeated. And there were Democrats who were important in the development of this process. There's a kind of deeper bench of support among the Democrats. But Tom Harkin, who was a crucial supporter from Iowa, retired. Ted Kennedy died. A couple of governors, Jim Doyle of Wisconsin was a great supporter of stem cell research, did executive orders in Wisconsin to develop a stem cell program. He was then subsequently, the next governor, Scott Walker, had no interest in this. Governor Blagojevich, you may have heard of, he was impeached. So the kind of people who helped us develop the policy or tried to get us to a bipartisan policy are mostly gone. And the times changed, and I think that's perfectly illustrated by these two quotes. This one says, and I'll give you a hint here, this one was 2001. I think there are ways to recognize the sanctity of life, but nonetheless, look at those clinics where the cells are sitting there, not going to be used to create life. I hope the president will find a way to agree there ought to be federally funded research. And this one, that stem cell research was the use of science to desensitize society over the killing of babies. The amazing thing about these two quotes is they're both from Newt Gingrich, former Speaker of the House of Representatives. And the difference is the first one's 2001, and this one's 2012 when he's seeking the Republican nomination for president. So there's been a change in the dialogue from a close to consensus, close to bipartisan view. If you ask where the people are, not the politicians, they've been supportive of stem cell research from the very beginning. There's Gallup polls on this every year, and it remains very popular. And now it's more popular than ever. 66% say it's morally acceptable, 29% say it's wrong to derive stem cells from embryos. Just to put that in context, they don't just ask about stem cells, they have a long list of things they ask about. Birth control is 91% morally acceptable. Medical testing in animals, 51%. I've just picked out a few. Abortion is below 50%. Cloning humans is very unacceptable. But medical research using stem cells, 2/3 of the country is comfortable with it. Still, we don't have much of a federal policy. Now, in parts, science has overtaken this. We may not need such a federal policy anymore. And he said, we talked about it, we had 21 cell lines. Well, that was done by executive order. And when Barack Obama became president, he simply lifted that order and told NIH, develop a plan for getting cell lines. And they did, and we now have just about 400 cell lines. So there's this 80-fold increase in cell lines. And plus there's hundreds available from other countries doing stem cell research, particularly Canada, the United Kingdom, and the European Union. And this new technology of IPS makes an unlimited number of such cell lines. And so the argument that we had all this stuff about got passed over by the science. We're past it now. The Bush Compromise, I think, is actually very important now because we've got the cell lines, and if the principle then was once the cell line's made, it's made, and we're not going to go back on it, then we've got the stuff to do most of the research you can imagine. That's about how you make an IPS cell line. I'll skip that. I want to shift one of the two last topics I want to take on. One is, okay, so what are people arguing about these days? They're arguing about fetal cells. And why should we want fetal cells? We've got all these cell lines. Well, Dr. Anderson can tell you, if you're trying to construct a nervous tissue, let's say a spinal cord, you don't need one cell, you need multiple cell types. This is a tissue that has several different cell types that interact. And so you need more than just the neurons that transmit it. You need these support cells, and you need these cells to wrap them with a myelin sheath, and you need something to make the right proportions of 3 different cell types. Well, that's not so easy to do from a pluripotent cell. You could do it from 3 of them, but how do you mix them and what proportions and so on. Better is to get a cell that knows how to make all 3. And you can find those cells in a fetus. And so for multiple cell types, at the moment, this is one of the best sources. There's a lot of regulation if you want to do fetal cell research. There are several pieces of legislation that govern it and other federal regulations. But basically, you can't buy any of the tissue. You can reimburse costs, but you can't buy anything. The donor has to know it's for research. The researcher has to know that it's only for research. And the physician must certify that the decision to abort preceded the decision to donate. With the notion, I guess, that people might actually be tempted, be induced to have an abortion by the thought that there is some gift involved here. Seems a little far-fetched, but that's the rules. This has led some activists, the anti-abortion world, to get involved. There was, in 2015, the release of some very highly edited videos purporting to show the sale of fetal tissue at a Planned Parenthood clinic. 12 states investigated this. None came out with anything. The Planned Parenthood has changed its policy. It will accept no compensation whatsoever for donation, for research materials. There was a congressional panel called the House Select Investigative Panel on Infant Lives, which was not about infants, it was about fetuses. And they demanded names, including the staff who might be working in these clinics and so on, subpoenaed research records, demanded information, including from us, and issued a report, which resulted in a vehement minority report that disagreed with everything in the report, and closed up shop for a while, and the chair of that committee is now running for the Senate in Tennessee and is favored to win. There have been recent developments in this area. NIH has undertaken a comprehensive review of its use of fetal cells. The Food and Drug Administration canceled a small contract, about $16,000 contract, with a company called ABR, who is the main supplier of fetal tissues to research labs. We don't know why they canceled it, and if it means that other programs are going to be canceled, this area will certainly be impinged. So I want to shift to the last part. Finally, I get to the ballot box. I quote one of my heroes, Justice Brandeis, who said that a single courageous state may serve as a laboratory and try novel experiments. California was that single courageous state. In 2004, stem cells went to the ballot in this state. And Prop 71 created a state agency that you've already heard about, allocated $3 billion for research. It had a great campaign. The proponents raised about $37.5 million. The opponents had about $500,000. It was a very one-sided campaign. 7 million votes were cast for stem cell in this for stem cell research. There was a 2 million vote margin. So it won statewide. This was the election where Bush was reelected. California went for Kerry by 10 points. It went for Prop 71, 59 to 41, so 18. If you look here in San Diego or Orange County, let's just look at Orange County. Bush carried it with 60%, 60 to 39, 52% for Prop 71. I had this notion that maybe San Diego and Orange County were influenced by the University of California. I helped. So I looked at a large Republican county, Kern County, where Bush won 2-1, and even there, the Prop 71 ran way ahead of the Democratic ticket. There's only one way to interpret these kinds of numbers, and that is there have to be Republicans voting for stem cell research, along with many Democrats. That this has a broader reach, broader support than any single one party. Prop 71, I'll leave to Mitra to tell you more about. I just want to point out one thing. It makes it a constitutional right under the California Constitution. We can't do the US Constitution here, but in California, you have a right to conduct stem cell research, so nobody can make it tell you can't do it. It's also an interesting governance structure, which is much more like American Cancer Society or the Diabetes Association. It's patient advocates and the scientists basically run it, and not the politicians. Following our lead, a number of other states voted. An interesting one was Missouri, which didn't put any money into it, but said, you can't make anything more stringent than the federal government is going to allow. It was a vigorously fought battle. And it was basically just saying, we want to be able to do stem cell research here. Don't put new rules on us. Former senator, very popular, John Danforth, the current governor, also a Republican, were supportive. And it passed in a very narrow 50,000 votes out of 2 million cast. Also led to one of the better cartoons that I've always liked, where he asks, how's cloning going to cure Parkinson's disease? By using a flux capacitor from Michael J. Fox's movies about Back to the Future. There was one failure at the polls. It was in New Jersey. Maybe a little surprising. It's known as the loan to clone election. New Jersey had already put a significant amount of money into stem cell research, mostly in facilities. And they had a ballot proposition backed by the governor, Governor Corzine then, initially polled very strongly to put a lot more money into it because they wanted to compete with California. And there was vigorous opposition, including by Right to Life groups and also by a political action committee called Americans for Prosperity, which you may recognize is the one run by the Koch brothers. It lost in a tight but not ultra close election. They had low turnout. It was an off-year election. It was the only thing on the ballot. They had a poor media campaign, and they keep talking about they're going to go back and do it again, but they haven't. Similar to the Missouri one, Michigan had a similar one of what the state legislature had put some restrictions on. There was a ballot measure and approved substantially to simply say, let us do it. Again, it doesn't put money into it. This has been a source of considerable contention politically within Michigan, where the state senate and the university and the proponents don't agree on how to interpret it. But it was a clear statement by the voters of Michigan that they were fine with stem cell research. So if you look around the country, we've got this crazy quilt. We've got states here where they've had legislative or ballot propositions in the dark blue or purple. Two states in particular put a lot of money in, California and New York. A few other states, Massachusetts, Connecticut, New Jersey, Maryland, put in some money and have supported. A number of states where they're supportive, but not investing state dollars. A couple of states where the governors moved on it, but then they were replaced and nothing else happened. Then you've got some states where there's all kinds of restrictions. And then you've got 5 states where they will put you in jail for doing the experiment California will pay you to do. Only in America. Nobody has been put in jail, I hasten to add, but at least it's theoretically possible. There are criminal penalties in there for doing. And there have been some changes at the federal level as well, mostly in how the regulatory agencies work. The Food and Drug Administration has begun to pay attention not so much to stem cell research as to people claiming to do stem cell research. Sent out warning letters, closed one clinic, and the Trade Commission, Federal Trade Commission, sent out warning letters saying stop advertising stuff that's not really stem cells. Because around the country there are all kinds of places popping up that are claiming to offer stem cell therapies, particularly here in Southern California. Other high density areas are Florida and a lot around Denver, which are mostly sports medicine places. These are places that are offering, advertising, promoting stem cell therapies that have not been approved by the FDA. There is some recent legislation in this area. The 21st Century Cures Act, passed in the last moments of 2016, tries to expedite the approval process for stem cell therapies, all kinds of cellular therapies for cancer therapies as well, as feeling that these clinics are popping up because people are anxious to get to it. And there's something called federal right to try law, which probably doesn't affect stem cells very much. It mostly affects cancer therapy, but it basically gives the right to an individual come in and demand a treatment that's still in the experimental phase. So here we are. We're in the middle. We have folks demanding treatment. This one happens to be in Rome, Italy, but it could be any place in the US. We're here, we want our stem cells, the politicians are stopping us, and we have people demanding that we stop doing this research entirely. And we're just in the middle trying to do the right research at the right time. It makes me feel very much like the old statement of the pilots who had to go over Nazi Germany, that if you're taking flak, you must be over the target. We've been taking flak, and I think we are over the target. And I'll be glad to take on some questions. Yeah,
What stem
John.
cell therapies have been approved?
Well, like I said, let's start with bone marrow transplants. They've been approved since the 1970s. Everything else there have been a couple that are moving along, but I'm going to leave this for Mitra. She's going to tell you a lot more about what's in the progress. But there are a couple that are coming along very quickly. Yes.
My interest would be in the ethics of this. You said you were involved in the ethics and the laws creating those, and in particular, because we happen to be on the property where one of the biggest fiascos happened in terms of IVF. I'm kind of curious what oversight, research, the provision of material for research and all of that has. Where does it come from? Who's watching? Who's finding the stories?
Sure. It's a very good question. The question was about.
So two things. Sid, can you repeat the question?
Right.
And then I just want to make sure we have time for Mitra.
Okay.
So then maybe can we pause Mitra's presentation and we'll take whatever questions everyone has from the
Okay.
end.
But I'm glad you brought this up because it's a crucially important one. And I will try to give you a very brief explanation because I give a course on this, so it's hard for me to condense it down to.
That means he's used to giving a 50-minute lecture.
I sit on the ethics committee.
So we take our responsibilities very seriously. We have, from the start, had an oversight committee. Anything that uses human stem cells has to go through an ethics review on this campus. I don't speak for anybody outside. We have a requirement that every protocol, every procedure, every change in it has to be reviewed. We have a consensus about about what is required for donation. And very briefly, the required for donation is informed consent that is non-compensated. It must be altruistic donation of material. So if somebody's going to give you gametes, egg cells, sperm cells, blastocysts, skin cells, we're not going to buy them from them. They have to know what the uses are, and they have to agree to that, and then disclaim any ownership thereafter. So we have, I think, a very stringent set of guidelines about how to do this and how we're going to accept these materials and use them and monitor their use. So let me stop there because we need to get to what's really going to happen in the future. This was your history lesson.
All right, just before we mic up Dr. Hooshmand here, a quick introduction. So I mentioned that there are two people here tonight that are kind of near and dear to my heart. Sid, for all the reasons that I explained at the beginning. Mitra, actually, because she was one of my very first graduate students and one of the first students that came to my laboratory at UCI to work on stem cells and to work in spinal cord injury. She was extremely pivotal in the work that led forward from our groups, Dr. Cummings and I, towards clinical trials for spinal cord injury, and she dealt with all of the ups and downs, and believe me, there are a lot of ups and downs that are a component of that. And for perspective, because it's not always obvious to folks that are outside the research community, this is a real sacrifice. I have always been hesitant to have graduate students be involved in this work. The graduate students and postdocs, post-PhD folks in the lab that worked on this are really making a potential sacrifice in terms of their careers to do translational research. And so Mitra really deserves a big nod because UCI was just getting off the ground in that direction, and certainly our labs were just getting off the ground in that direction when she made the choice to come and do that. She's since moved on in her life, and she is currently the Director of Scientific Programs for Americans for Cures, and she is going to tell you about that. So.
Thank you, Eileen. It's amazing to be here. I don't know that I deserve the credit that Eileen just gave me because I think a big part of the reason why I stayed and made the sacrifice that she's talking about is just to be able to shadow her and have her as a mentor to guide me, which really brought me to where I am today. And we'll leave that conversation for another time because that could take up a whole hour. But what I am here to talk to you about today is the perspective that I've gained being on the other side of science, which is more on the education and advocacy component of it. I spent a very long time on the basic science and translational end of science and recognize the potential that stem cells have for treatment of many different diseases, in particular with my work in spinal cord injury. And then I made the transition and realized that this is actually affecting the lives of real patients. And in that moment of recognition that there could be ways that we could treat real people with real faces, people like Jake and Evangelina, with stem cell therapy, that was when I realized that we need to keep this going forward. And I'll tell you a lot more today about the importance of continuing this kind of research and how hopefully many of you can be a part of that and help. Unlike most other lectures that ask you to put your phones away, I'm actually going to ask you to take your phones out for a moment if you have them on you. Not everybody has to participate, but if you have them on you, we're going to do a live poll. And all I need you to do is go on menti.com and put in that code that you see there, 657212. And you're going to be asked the question, and I just want you to answer the question yes or no. And I'm actually going to take you. You went too fast. It's going to come up. There you go. So 65, 72, 12. So far we have about 11 people who have voted, and this is the live result that you can see. We'll wait a little bit longer until we get everybody's numbers in. Not everybody may vote, so we won't wait forever. But I'll tell you once all the results are in, the results that we can compare this to. What's that? Oh, you can't get online. There's no reception up here. Interesting. Or I see the Wi-Fi doesn't allow you. Well, we'll be fine even with half the population. The numbers are starting to be close to what we expected. We'll wait till maybe they reach a little bit higher. But as you can see already, the trend is that most people know someone with a chronic disease. It's possible that some people have said, I'm not sure, because they're not exactly sure what a chronic disease is or what's considered a chronic disease, and that's okay too. I'm sure that as we go through this discussion that may become more clear, but it's a large percentage of people who know someone, just in this very room, who is suffering from a chronic disease. Now, in the next question, if you stay on the same code, you should be able to see the next question, and you can vote again on how much you think it takes in terms of healthcare expenditures on an annual basis to treat chronic conditions. Do you think it's between 1 and 10 billion, more than 10 billion, about $1 trillion, or more than $1 trillion? Okay, well, take a guess. What do you think? How many people think it's the first one, 1 to 10 billion? Okay, more than 10 billion? About $1 trillion? And how many think it's more than $1 trillion? Okay, so the last two are actually options for some. So let's take a look at the answer. And I will show this to you on the slides. So it costs $2.3 trillion every year to care for people who are suffering from chronic and mental health conditions. That's a lot of money that we're spending to just care for people who are suffering from these diseases. Very much in line with the results that we showed in this very room, 1 in 2 adults has a chronic disease, and 1 in 4 adults has 2 or more. So it's very likely that you would know someone who is suffering from at least one chronic disease. So this is a big problem. Healthcare and taking care of people who are suffering from these diseases is extremely important. What's also interesting is that when it comes to voting, just like Sid had alluded to, most people care about the position that a candidate takes on pre-existing conditions, and that's how they vote for that particular candidate. So it's important to us because of the fact that we're spending so much money on healthcare expenditures and that we have family and friends who are suffering from these pre-existing conditions, which really means that we need to find a way to treat people who are suffering from these diseases. And of course, as I told you, I personally believed in the power of stem cells from the very moment that I walked into one of only 2 labs. And all of UCI at the time, when I was a grad student, only 2 labs were working on stem cells. Eileen's was one of them, which is why I pretty much stalked her until she allowed me to be a student in her lab. And in going through the process, I recognized the potential and power of stem cells. And of course, as we've gone on, we have started to see more and more of that potential coming up in clinical trials and the results that have been produced. But another person who believed in the power of stem cells was Bob Klein. Bob is not just the chairman of the nonprofit organization Americans for Cures that I work for, so I don't just like him because he signs my paychecks. But in addition to that, he is an extremely inspirational man who believed, as an advocate, that stem cells could treat his son. And his son was suffering from diabetes before Proposition 71 went on the ballot, and he believed that stem cells could one day help Jordan. Stem cells and stem cell research did not unfortunately catch up with Jordan, who passed away about a couple of years ago. But Bob's goal and Bob's belief in the power of stem cells has not diminished one bit. And when you talk to him, when you sit in a room with him and he talks about stem cells and asks questions about where the field is and wants to know every detail about it, you know that he still wants to continue to fight. And he wants to continue to push for stem cells and the research to continue to receive the funding that they have been over the past 12 to 13 years. And Bob is the person, like Sid was mentioning, who put Proposition 71 on the ballot. So in 2004, when the proposition passed to fund $3 billion over a period of 10 years for stem cell research in the state of California, that all started with Bob Klein. And as a result of it, CIRM, or the California Institute for Regenerative Medicine, was born, and $3 billion was beginning to get allocated out to labs across the state of California that were dedicated to doing stem cell research. As you know, 10 years has, you can do the math, right? From 2004, 10 years has passed. So we'll talk a little bit at the end about what has happened to the money so far that CIRM has been disseminating, and what is going to happen very soon when that money actually stops. But what has CIRM accomplished? I wanted to give you just a few brief numbers before I jump more into the actual results of the clinical trials. This is CIRM's portfolio just from 2017, so just this year. And as you can see, one of the biggest things that I wanted to highlight here is that there's a diversity in terms of what CIRM funds. So everything from education and making sure that the future generation of scientists are funded in programs like the Bridges program, which helps to educate young scholars so that they continue on to get invested in stem cell research, all the way to infrastructure, like Eileen talked about, this very building that you're sitting in, and many others that CIRM has helped to fund. And of course, translation, discovery, and clinical research, all of which are receiving funding from CIRM. And this is a very unique setup where CIRM is funding everything through the pipeline that Eileen showed you at the very beginning, all the way from basic science to translational and clinical funding, and allocating a very large amount of money to each of those stages. Again, as Eileen talked about earlier, CIRM has also invested in what are called alpha clinics, which there are 5 of at the moment. And this is the true state of the art when it comes to translation, and making sure that patients are becoming very familiar with the process of what it takes to take a stem cell therapy, for instance, from the lab all the way into what are the clinical trials where patients actually receive the stem cells. CIRM has also had a fiscal impact that perhaps most don't think about, that it's actually returning something to the state of California, $2.3 of economic activity on every dollar spent, and $2.1 billion of leveraged funding since its inception. So it's actually providing a return on our investment. And then, of course, there's the clinical trials, which are really the big landmark of how CIRM has developed. They tell us how far this funding has gone and what is actually happening in terms of translation in clinical trials with humans receiving the therapies that have been developed in laboratories. And this is a large part of what I'm going to be talking about today. But there's also been a lot of publications over the past 12 years. As you can see, over 2,600, and this number keeps rising, of course, on a daily basis, 2,600 of publications that have been directly produced as a result of CIRM funding, everything from, again, basic to clinical trials. So there are many clinical trials that CIRM has funded. We don't have enough time to talk about all of them, but there are 10 in particular that I wanted to focus on because they are, in my mind, some of the ones that truly deserve some attention. Of course, it's hard to say that because all the clinical trials deserve a lot of attention, but maybe these are the ones that are dearest to my heart. I'll start with the category of blood. So you're looking here at a young newborn, Ileana, who had received a stem cell therapy that was born out of UCSF from Tippy McKenzie's lab. Ileana was suffering from what's called alpha thalassemia, which is a fatal inherited disorder. So most babies, almost all of them, die in utero when they have alpha thalassemia. And this is basically an inherited disorder that causes the blood cells to have an abnormal hemoglobin, which doesn't allow correct circulation of blood. And most of the babies are either aborted because they will not make it all the way to term, or they will die in utero. but Tippy McKenzie has transplanted using the mother stem cells. Oh, wow, this is actually working. Using the mother stem cells into the child in utero. This is historic. This has never been done before. Transplanted the stem cells into the child, and Ileana was born. And she has been around for the last 5 months. She's doing well. She's healthy. And she's only getting blood transfusions at this point, which is huge for her. This is a really, really big accomplishment. Another thing that's huge about this particular trial is that it was funded A to Z by CIRM, all the way from basic science to the clinical trial that you're looking at. Ileana was the first and only patient so far transplanted in this trial, and the trial is in phase 1, which is safety. But unfortunately, because alpha thalassemia is very rare, it's also very difficult to find patients to transplant. So at this point, she's the only one. And then we have bubble baby disease. How many of you have heard of this? You probably have. Bubble baby disease is also a fatal disorder, but not in utero. Most kids who have bubble baby disease will die by the age of 3 or 4. They have no immune system, and so with the smallest infection, they will not be able to resist or fight, and they will die as a result. And what you're looking at here is a picture of Evangelina, who was one of the first girls to be transplanted with Don Cohn's stem cell trial at UCLA, where he takes cells from the patient, uses gene therapy to fix the cells because they're missing a specific gene that causes the child not to have an immune system. So he uses gene therapy, edits the gene, adds the gene that's missing, and then retransplants those cells back into the patient. 42 patients have been treated to today with this trial, and I know that Eileen has taught me to be very cautious about how I use the word cure, what I call the C word, but I feel very confident in this particular trial to be able to use the C word. 42 patients have been transplanted. These were babies. And all of them are living, they are at school in environments where they don't need to be in a bubble, and they're doing perfectly fine. So that is another huge accomplishment in the blood field. In the kidney trials, this is one of the trials that's currently sitting at phase 3, which is one of the later phases of the trials. Run by a company called Humacyte, where they're taking patients who are at end-stage renal failure, and they have a biomaterial that they make outside of the patient's body, obviously, and they seed this biomaterial, which is similar to a vein. They seed it with specific smooth muscle cells, and then they put this vein back into the patient. And this vein is meant to help with dialysis. So there are patients who are getting transplanted. The picture that you're looking at here, Frank, unfortunately has passed away. He was one of the recipients of this particular vein for dialysis, but he did not pass away because of the trial. This is just, again, like I said, it was end-stage renal failure, and he was in one of the earlier stages of the trial. Cancer, tons of progress in cancer. Melanoma, specifically, this is a trial that is being conducted at UCLA by Anthony Ribas's lab, and he has recently launched this project. This patient that you're looking at is one of the first and only patients who has received a stem cell therapy where the stem cells from his body are taken, and he also, very similar to Don Cohn's trial with bubble baby disease, he adds a gene to the cells that will boost them so that they continue to go and find the cancer cells and kill them off. So this is very similar to CAR T, if you've heard of CAR T. And Daniel here has received the cells. He's in a phase 1 trial, which is the very first phase, testing safety, and there aren't any data on him just yet. But this is a promising trial that we're going to be looking at in the future. In the blood cancer field, Irv Weissman, who will be here, as Eileen mentioned, in November, has developed an antibody called CD47, which is an antibody that goes around and finds cancer stem cells and kills them. And he has used this he developed this antibody by looking at cancer stem cells in a dish, and is now using the antibody in combination with a more common cancer therapy, cancer chemotherapy, to treat patients with cancer. And this is now being moved forward by a company called 47, and it has a lot of potential for not just blood cancers, but a variety of different cancers, and is currently being tested. And then we have a variety of trials in the field of neurological disorders. Spinal cord injury is one of those. You're looking at Chris Boson here, who was a cervically injured patient who was unable to use his upper limbs. He was one of the patients enrolled in the clinical trial that you see here by a company called Asterius, which takes human embryonic stem cells that are pushed to become a very specific cell type called oligodendrocytes, and puts those into patients so that the cells can remyelinate axons. So basically they can provide the insulation that nerves need in order to conduct electricity across. And this trial has also been extremely promising. It currently finished its phase 1/2, and moving on to phase 2, and has shown very promising results with a very large cohort and different dosages of stem cells transplanted. Duchenne muscular dystrophy, which is a genetic disorder which causes the loss or over time paralysis of muscles, including the muscles of the heart, is also another one of the trials. This trial is being run by a company called Capricor, and they are focusing specifically on rescuing the muscles of the heart in patients who are affected by Duchenne. And they're transplanting cardiosphere or heart muscles essentially into the heart of patients who are suffering from Duchenne. And Caleb, who you're looking at here, is one of the patients enrolled in that trial. Again, not a lot of data coming out of this trial just yet, but there are patients enrolled in it. ALS is another disease that I'm sure many of you have heard about, Lou Gehrig's. If you haven't heard of it, many of you probably remember the Ice Bucket Challenge. This is that disease. In ALS also we have a phase 3 trial funded by CIRM. This trial is being funded by or being run by a company called Brainstorm, who is taking stem cells, boosting them so that they make a lot of good food for the neurons in the spinal cord, and then transplanting those into the patients. And this has also had significantly good results, the most important of which has been changes in lung capacity of patients with ALS, which is extremely important because that's one of the reasons why many of these patients die. And lastly, eye diseases, including retinitis pigmentosa, which has a trial being run out of UCI by JSITE. Henry Clausen, who you may know, is transplanting stem cells to help rescue patients who are suffering from eye diseases like retinitis pigmentosa. And there's another trial for macular degeneration, which has also had very good results by Peter Coffey, and another trial actually for macular degeneration out of USC that's being run by Dr. Humayun, and also has had multiple videos actually published recently on YouTube about how well the patients are doing as a result of it. So just a handful of trials, but all of it to show that the money that CIRM has put in is returning results. The results may seem slow, and when I say results, I don't necessarily mean at this point yet that we have a therapy, but to me, results are progress in the pipeline. And the very fact that we can see clinical trials that are moving down this pipeline, we see research that's moving down this pipeline all the way to the stage of clinical trials, some in phase 3 trials, in my opinion, is huge progress and a huge result. I'll skip through these and I'll just end with the future of STERM. So we've come far as a state. As I told you earlier, we have been able to create tons of jobs as a result of voting for Prop 71. We have continued to bring in an influx of really, really smart people to be inside our buildings and doing the research in the state of California. In 2018, there's still some more work to be done by STERM. But what you may not know is that in mid-2019, STERM is going to run out of money. And STERM is currently looking for bridge funding so that they can bridge this gap between 2019 and 2020, which is really their absolute expiration date. So what will happen in 2020, what will happen in 2020 is we need another ballot initiative. And one of the things that I hope, and Bob has been very, very inspirational and supportive of, is making sure that this ballot will go back on to the 2020, this ballot initiative will go back on in 2020, and all of us will be voting for it again. But in order for Bob to be able to lead this, he needs a coalition of supporters. He needs people who also believe in the power of stem cells, people who can go on and tell the stories of some of the patients that I just shared with you, to tell the stories of everything that you've been learning about over these community lecture series about what stem cells do. Because if people don't know what stem cells have accomplished, if they don't know the potential power that we're going to be losing if we don't continue to fund the research, they're not going to vote. And this is a time to educate. So anything that you've learned, any story that you have, anything that you think can help, whether it's financial, whether it's just a story, whether it's just one thing that you learned today or at any of the community lectures, if you go back and share that within your communities, you're supporting stem cell research. And with that, hopefully this will become a contagious effect where more and more people in the state of California will start to understand this power and this potential. And when time comes and we all need to go back to the ballot to vote, our answer will be yes. And I'm going to skip this, and with that, I will take any questions as well. Thank you. Sorry, you had a question. Yeah.
Yeah, I do. Has there been any clinical trials or anything in the field of OBGYN? That's my field. And we're doing a lot of studies right now in what the stem cell can do in oncology, in cervical cancer and breast cancer. Now, you're looking for funding and everything. When you look at the mortality of women, it's breast cancer and cervical cancer is like up to the sixth highest level of mortality. Mm-hmm. So I would suspect that somewhere there's got to be research in there. This is what people understand. We have all kinds of things. We need research more in this area.
Yeah, and there are different basic science labs that have been funded specifically for both cervical cancer and breast cancer. There are no clinical trials currently with either one of those specific types of cancer, but some of the more general therapies, like the CD47 that I discussed about, Irv Weisman's trial, could potentially help and have an effect for even breast cancer or cervical cancer or other types of cancer. So there's potential there, but nothing in clinical trials specifically for OBGYN, not yet. After 2020.
Regarding that macular degeneration, you mentioned 2 people, one at USC. Could you repeat those 2 names?
Yes, and I can share them with you afterwards too. One is at USC, Dr. Humayun, Humayun, and in collaboration with Dennis Clegg, Clegg, and the other is Peter Coffey in the UK. well, he's mostly in the UK.
UC Santa Barbara.
He himself is at UCSB.
But the trial is being held in the UK.
Yeah.
On that same topic, is that wet or dry macular degeneration?
Very good question. So both of those are dry. There is another trial, though, not SHRM funded, that was run by Steve Schwartz at UCLA that targets wet macular degeneration.
Most popular is dry, I think. right?
Yes.
You use the expression in the patient's own stem cells. From where are those harvested?
Depends. Where did I use that expression specifically? Do you remember? Because it depends on the trial. The skid baby, probably. Most of these are hematopoietic stem cells, so they come from the bone marrow of the patient, and then they're modified and retransplanted. Obviously for reasons of not having rejection, right? Because if it's coming from your own body, then the chances of you rejecting it is a lot less.
Thank you.
Can you comment on cord blood stem cells, the adult stem cells?
I think that's you.
Let me take that one. The question was about cord blood
sorry.
stem cells, and it's a very common question. Cord blood stem cells are another version of bone marrow stem cells. They are known and established and very useful for blood replacement. So for leukemias and certain forms of severe anemias. There are ways you can do this. There are public banks where people can contribute the umbilical cord blood that was otherwise going to be thrown away, and they create a bank of these, and then you try to match the needs. Of course, there isn't a lot of blood in the umbilical cord, so sometimes they'll need 2 or 3 or 4 of them in order to use them. But it's for when they don't have a matched donor. Then there are commercial ones which will store it and tell you, you'll have these stem cells available for this baby for its lifetime. The problem with that is that we don't know what they're storing it for. That is, if it's for the known use and established use for a leukemia, that's a rare disease. So you're doing a lot of expense. It's like buying an insurance policy against being hit by lightning. It's not going to happen very often. So I'm all in favor of the banks. I think they're terrific. They provide opportunities for patients who otherwise might not get treated. But the notion of storing it for your own use or your own baby's use is a long shot.
Are you familiar with Dr. Neil Warden in Panama City, who's using cord blood stem cells? He calls them the golden cells. He's identified certain cells and proteins within those cells that he's culturing and treating patients.
I'm not familiar with this doctor or his program at all. I should say that cord blood also contains a small number of what's called mesenchymal stem cells that can be used for connective tissues. Its use is very much debated in whether these are at all useful for other diseases. It's not established that these kinds of cord blood derived cells can actually be used to treat another disease other than the blood diseases.
Sorry, I also just wanted to comment. I actually do know of Neil Riordan, and the challenge with his clinic is that, there's a reason why it's not in the US. Being in the US means that you have FDA approval to actually do the treatments that you are. And B is that I have not been able to find any published publications from him that actually demonstrate that there is an efficacy in terms of his transplantation. So he has a lot of testimonials, a lot of anecdotes of people talking about seeing improvements, but as we know, the placebo effect is a real effect. As a scientist, I'd like to see the evidence, and I haven't found any.
Claims that the cells are currently approved for clinical trials in Florida for spinal cord injury, and muscular dystrophy in young children.
Are they? So I'll take that piece. It's complicated. So in the US, there's one place that a clinical trial authorization can take place, and that's through the Food and Drug Administration, through the FDA. So you actually can't get authorized in an individual state to conduct a stem cell trial or for any kind of therapy, right? Much less gaining approval. That's a federal level regulatory issue. And so it's not possible to be authorized or approved for any type of medical treatment in an individual state. So thing one. Spinal cord injury is a significant part of what the research is in my lab. And there, I'm glad to talk to you afterwards, but just kind of for perspective and general comment, here the stem cell population that's relevant from an umbilical cord stem cell is called the stromovascular fraction, or the SDF fraction. And the catch with these cells is that they don't engraft in the central nervous system. So what do I mean by that? If you inject them in the blood, which is what most of these similar trials do, they'll circulate for a period of time, but they actually don't like the central nervous system. For example, for spinal cord injury, they don't cross the barrier and they don't stay there. Actually, where they go to is the lung predominantly. And this has led to some real problems, especially with ex-US, outside the US, cell therapy clinics that have sprung up. Really the point I wanted to get to there that's just important to recognize in terms of unauthorized stem cell clinics is it's easy to think that these cells are magic and they can't do harm, but they can do harm. And so there are some particularly classic examples of umbilical cord stromovascular fraction cells or different types of mesenchymal stem cell populations in spinal cord injury in South America, where individuals have traveled from the US, from the UK, from other places in Europe, and never gone home because those cells like to go to the lung and they cause pulmonary embolisms, and people with those conditions can't tolerate that kind of stress. So these cell populations can cause harm, and it's very important to be careful and working with a reputable clinic that's working for a full authorization process, like the alpha stem cell clinics, where there's a regulatory body that's in place.
I'm a nurse, and I was recently introduced to a pharmaceutical company called Invitrix, and they're right here, I believe, on California or Health Science Road, and they're selling cord blood stem cells to doctors' offices for IV use and joint injections. So I'm curious.
Yeah. So this is Sid, you showed the diagram of from Lee Turner's work.
Yeah.
Yeah.
There are many such clinics, and at the moment, we don't know how many what all of them are doing. The best evidence is that most of them are doing joints, that's why there's a cluster in the Denver, in Colorado, with the kind of sports medicine orientation. They probably can do the least damage there. Whether they're helpful or not needs to be established. The second most common use is cosmetics, body remodeling, and
It's all good.
and the third after that, way down the list, is neural and vision. The neural and vision have the most incidence of adverse events. They're the trickiest, and I personally believe that it is risking life, limb, and sight to have an unauthorized clinic doing those kinds of trials.
They say they're immune privileged, that there doesn't...
Yeah, we're glad to discuss this, but I don't want to have anybody. The fact remains that there have been several people treated in this fashion in clinics around the world and are now blind. So I'd rather not see that happen.
I'll stay and talk as long as you want. So, but maybe there are a few other questions that people would like to sneak in here.
Oh, come on, don't be shy.
Well, I got one, if no one else.
I knew you would go. I was counting on you.
You're counting on me? Okay. I'm a Bruin, by the way.
There you go.
No Bruin. What is the medical prospect or the medical opinion now about stem cell research for heart failure patients, whether it's from a heart attack or some sort of a cardiac event?
A large piece in today's New York Times.
That doesn't work.
Not working.
Here, go back.
On this. So the question is about heart failure.
Sid, step back. There you go.
This wasn't working either.
Yeah, I don't think either of them.
Is this?
Really?
No, everything's turned off.
And
Yell
by the
louder.
way, I've heard positive and negative.
There is almost no evidence of regenerative capacity within the heart. And is much debated. The question, in my view, maybe Eileen, Mitra disagree, is not whether the heart can regenerate, because I think that is shown not to be the case, but whether you can put a cell in the heart to make it regenerate. That's an open question. There are labs that are working on that. But the stuff that is the breaking scandal at Harvard is a claim that they could actually do it out of the endogenous cells of the heart. And there's no evidence, I think, that that's happening.
So does everybody get the question in that regard? So there's this large set of papers that was just retracted, means withdrawn from the literature by a particular group at Harvard, where the claim was you could make new cardiomyocytes, you could make new heart muscle. But as Sid is highlighting, that's probably not the case. It doesn't mean that the clinical trials that are currently ongoing for chronic heart failure, congestive heart failure, aren't promising. It's just that the mechanism is different. And it's a case of the science kind of catching up with where things are, because most groups, most laboratories doing active research in this area have thought for a while that it's other mechanisms that are important. So there's a host of literature out there, a lot of studies saying other mechanisms of action, and that's why those clinical trials that are ongoing now have gone forward. So the big splash that's been in the media over the last week or two doesn't necessarily blow up the whole field, if that makes sense.
I just wanted to add, since you are a Bruin, there is a Bruin, Dr. Rez.
Bruin, by the way.
Oh, you're not a Bruin.
He's a
Die
diehard.
A diehard Bruin. Okay.
There's a difference between a Bruin and a diver.
Diehard Bruin. Okay, so you might want to look up Reza Ardahali, who is doing basic science research on developing human embryonic stem cell derived cardiomyocytes to transplant back into animals. And is showing very promising work. He's a STEM-funded scientist, and who knows, his work could go on. He's also a cardiologist himself, so cardiologist and doing research. So he's in contact with the patients all the time, and is coming at this from a very clinical perspective. So his work seems promising and could go on in the future to clinical trials.
So 9 years ago, I had a stroke, and I've lost my sense of smell and taste. Is there any chance that stem cells could help?
Wow, that's an unusual effect of a stroke. So the question is, if you, secondary to a stroke, if you lost one of your senses, smell or taste, for example, is there a potential for replacement of that? It really depends what the cause was. So I understand a stroke, right? But whether there's a particular bit of brain that was affected in a way that yielded cell loss. So we know that, in fact, there's a lot of testing underway with different types of stem cell populations, everything from neural stem cells to mesenchymal stem cells as a mechanism, as a way to ameliorate the effects of stroke. Most of those get conducted in preclinical work very early on after the initial insult. And so the key so far in terms of those studies has been to try and intervene relatively quickly and get to some sparing of function, right? To increase recovery by virtue of minimizing the amount of initial damage. In a situation where we're moving out towards a much more chronic situation, that's a murky area right now. It's a little bit gray. And I don't know of anyone in stroke that's working in a very delayed paradigm, a delayed type of experiment to be able to get repair. Those caveats said for stroke, in spinal cord injury and traumatic brain injury, where I'm very familiar, Dr. Cummings, who's sitting next to you, works in traumatic brain injury, very tightly related to stroke in terms of mechanisms. And there's a fair bit of new data coming along the pike that we actually can give stem cells in a much more chronic period. So months after injury in animal models, which we normally equate to being more similar to years in the human setting, and still see recovery and repair. Unclear the mechanism at this moment, whether the cells that we transplant are actually replacing cells that were lost, which is what we all thought stem cells were going to do back in the day, or whether we're sort of waking up an endogenous repair process. Brian, for example, has a very active research program that's trying to discriminate those two possibilities right now. So no trials down the pike in that direction, but I actually think there's an awakening of interest in being able to try and go to those much more chronic periods with potential treatments in the future. Brian, would you add to that, or?
Well, so I would add that the complicated part there is when you have a stroke, you might have disconnected part A from part B, or part A died, and so the therapy of replacing part A again so that it could connect up with part B, the olfactory neurons that are still there. That would be one therapeutic approach, versus if you could repair part A but there's no part B left to talk to, you're still not going to have recovery of olfaction, of being able to smell, for example.
Because it didn't happen right away. It happened slowly over about a 3-year period.
Yeah, that is very perplexing.
That's exactly what my doctor said.
Yes.
You will be in medical journals.
Journals, yeah.
Because I showed no signs of the severity of my stroke, except I can't smell a damn thing and I can't taste anything either.
They're usually related.
Yeah.
I'd be happy to do more. I'd be happy to talk to you afterwards, but any more questions for?
I think I saw one other tentative hands in this direction. You don't have to. No? Yes. Okay.
About the clinical trials and the real patients. For example, about the regenerative pigmentosa, as I know, this is not a stem cell transplant, it is pure gene therapy.
So your question is whether or not the trials that SERM has funded, especially the first one, alpha thalassemia, seems like it's just gene therapy and doesn't involve stem cells.
As I know, 100% retinitis pigmentosa treatment is just only for one specific form of mutation, because retinitis pigmentosa have multifactorial and it has different genes, and only the treatment is done for the patient that have a mutation on R65 gene, and the drug is named Luxturna. It has FDA approval, but it is pure gene therapy. And also about alpha thalassemia, this is not stem cell therapy, it's a gene therapy.
So I don't know about the drug that you're talking about, nor do I think retinitis pigmentosa is specifically a gene-related disorder. But about the alpha thalassemia trial, that is actually a stem cell trial, because the stem cells are taken from the mother, modified using gene therapy, and then replaced back into the patient. So it is actually using stem cells to do the transplantation. Having said all of that, there was a debate just last week on the SERM board meeting about whether or not the future of SERM would also categorize gene therapy in general as an area of funding. So not just focusing on stem cells, but also gene therapy. No vote has been given on this yet, so we don't know. It may or may not happen.
Are you going to comment?
Yeah, I'll comment on the retinitis pigmentosa. The study here at UCI is not limited to one mutation. There are several thousand different mutations that have been identified that lead to retinitis pigmentosa. This is the trial here is a pure stem cell trial, not a gene therapy trial. Now, I don't know about the drug that you're talking about. That may be targeted to one
Specific
phenotype.
Yeah.
mutation.
And then maybe just to, let's just back up for a second and explain so everybody in the room is on the same page here. So gene therapy, which is a very active area of research in the US, and I think it is an important one from a clinical translation perspective, has some flaws for particular sorts of diseases, and that's how we can deliver effectively. Right? So if you're trying to treat a young child, if you're trying to treat in utero, which in some cases, alpha thalassemia being an example of that, you have to get delivery very, very early. And the only way really that has been effective to be able to do that is through a stem cell population. Why? Because this is what stem cells know how to do, and we don't know how to do. So if we can replace a stem cell population so that that child, in the case of the genetic disorders we're talking about, engrafts, right, takes those cells, makes them a part of their system. They make a new hematopoietic system, a new bone marrow system, a replacement cell that stays with that child for the rest of their life. That's how we get to something where we can start using the C word that Mitra mentioned. And the only way that we can currently do that is via delivery through a stem cell population. And that's what those trials are all about. So we may be modifying the cell with gene therapy. That's true. That's bringing together two different strategies for therapy into the same place, but is being delivered by a stem cell product. And without the stem cell, you can't achieve the therapy. Does that make sense? Okay.
Okay.
Yes.
Let people watch the rest
Thanks
of the
everyone
series.
for coming tonight.